Corporate finance practice problem using Excel. Calculation of bond value with different yield rates. Problem 1. Get ready. It's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We're going to have the information on the left-hand side. We're going to use that information to populate and calculate in the blue area on the right-hand side, having a few different types of scenarios with this practice problem. We're going to be calculating the bond value of the bond, information that would be basically, you can imagine this as if you had the paper bond here, and what would actually be on the bond would be the par value. We're thinking that's going to be 1,000. That's going to be kind of our standard for our problems here. And then we're going to say the percent is going to be 10%. That would be the issue price, or the amount, once again, the rate that would be, you can imagine, basically on an actual bond. And we're going to kind of use 10% as a standard price there, but you can also note that when issuing the bond, of course, then you might issue what you would think would be the market rate at that point in time. And then as things change over time, the rate on the bond will most likely differ from the market rate or yield. Then we have it's going to be maturing in 15 years. So we can derive that at least from what's on the bond. What is not on the bond is the market price, the market expectations. Once again, when you issue the bond, then the market information hopefully would be similar, because we would be choosing a rate that we would think would be the market rate. But then as time passes, you would think those things would then differ. So we could have a different market rate or market expectation. And then we're going to have to use that to figure out what we believe the value of the bond is. Now, note that if you issued the bond, of course, for the market rate, and you had it out there at that point in time, meaning the market rate and the bond rate, the rate on the bond are the same, then the value of the bond would be the $1,000. However, and if you did this calculation, we won't do this calculation for the 10%, but if you can do that as a practice, and you'll actually get, you'll get to the $1,000, you should. And then if the rate is less than, the market rate is less than the rate on the bond, then you can kind of imagine the bondholder as having like an advantage in that situation, in that they would want to sell the bond at a premium, because you can imagine the person on the market cannot buy a similar bond and get a 10%. They would be looking for the 9% would be and therefore you can't change the rate on the bond because it's already been on the bond. What you can do is then sell it for something greater than the face amount of the bond. If, on the other hand, the market rate is greater than the rate that's on the bond, market expectations, meaning people on the market can get a return they believe at something greater than the rate that's on the bond, then in order to sell the bond, you're going to have to sell it at something less than the face value of the bond, the amount on the bond, the par value of the bonds. So that's going to be the basic idea of it. So now we want to go through the calculations of it. Note, it's a great calculation for present value types of calculations, because we have both a series, an annuity type of calculation, and we have a present value of 1. So when we present value these things, then we have a series of payments that are going to be 15 payments in this case. We're going to say that they pay annually 10% of the $1,000 par value. And so we can present value that series of payment, and you're going to get the 1,000 at the end of this whole term. And so then we have a present value of 1. So we have two components: present value of an annuity, present value of 1. So we'll do these calculations a couple different ways, as we have seen with prior present value types of calculations. We're going to start off with this 9%. We're going to assume then the market rate is going to be the 9%. I'm going to make that green for our first calculation. Now, because the market rate, people on the market, you can imagine yourself as the issuer or the buyer, right? And as the corporation, you'd imagine yourself as the issuer, which might be a little bit unusual. If you're, an investor, then it might be a little bit backwards for you to think. You could think of yourself as the purchaser as well. But if you're the issuer and you have these bonds, and people elsewhere can only get bonds at 9%, and your bond pays 10%, then you're going to want to sell the bond at a premium, something greater than the par value. So we would expect then the value that we come to be greater than the 1,000. Let's see if that's the case. First, we'll calculate the annuity. We could do that with a formula, and then we'll do it a couple different ways. The Excel function is probably the fastest way to do it in practice. So we have P times 1 minus 1 plus R to the negative N over R. P is going to be the amount of the payments, which is 1,000 times 10%. 1 minus 1 plus R. R is going to be 10%. We're going to assume it's annual, so we'll keep it there. Minus to the negative 1. N, which is 15 periods, over R, which again is 10%. I'm going to put that into a table format over here, putting P all the way to the right side, which is going to be equal to this 1,000 times that 10%. This times that. There's the $100. Then we're going to take the 1. I'm going to put that in the inner column. Then I'm going to pick this 1 plus R to the N. Going to pull that inside here. 1. R is going to be then the 9% down there, 9%, percentifying that, home tab, numbers, percentify, underline, home tab, font, underline. Then we're going to add that up with the trusty sum equals SUM, and adding those two up. And then I'm going to percentify that, home tab, numbers, percentify, taking that to the power of the number of periods, which is negative 15. That's the number of years. Going to then underline that, home tab, font, underline. Pulling this then to the outer column, this calculation, which is going to be the 109%, shift 6 or caret to the negative 15. We need to add some decimals so we can see some stuff there. Home tab, numbers, decimalizing it. And then home tab, font, underline. We can then subtract, finally getting to the end of the numerator calculations. That's going to be the 1 minus that whole thing. Adding decimals, home tab, numbers, decimalizing it. Then we're going to divide by R because that's the denominator. That's going to be the 9% again. Let's percentify that one. Home tab, font, percentify. Pulling the answer into the outer column, taking the numerator, divided by the denominator. Adding decimals, home tab, numbers, decimalizing it. Underlining it, home tab, font, underlining it. And then we could finally multiply the outer column to get to the result of the annuity. Let's add a couple pennies here. Home tab, numbers, couple pennies have been added. Okay, so the fastest way to do this would be to do like the annuity function over here in Excel. So the present value of an annuity would be negative present value, shift 9. Rate would be the 9% there, 9%, comma. Number of periods would be the 15. So we pick up the 15 periods, comma, because they're annual payments. If they're semi-annual, you got to be a little careful there. And then the payment amount is that $100, or we can recalculate it just to make sure we see where that comes from. The 1,000 times the 10% on the face value, face of the bond, and that will give us that 106.07 again. We can also present value our annuity as a series of present value of ones as opposed to the present value of an annuity. To do that, let's go 1, 2, and then sum these on down. Easy to do in Excel, good practice, and good times. So let's do it. And then we're going to go to the Home tab, Alignment, and Center. The payment's going to be 100 again, which once again is that 1,000 times the 10%. And then we'll present value this. This is present value of 1, not an annuity for 1 period out. Present value, shift 9. And that's going to be the rate. I'm just going to pick it up right here this time, comma. Number of periods, just 1, because we're looking at the 1 payment, the first payment, comma, comma, because it's not an annuity, and then picking up the future value. There we have that. I'm going to pull that into the outer column, do this one more time. All the payments are going to be the same, $100. Present value, once again, of 1, present value, shift 9, rate 9%, comma, number of periods 2 this time. This is the second payment, comma, comma, because it's not an annuity, and then the 100 for the future value. That then gives us the prior result, 92, plus the current result, 84. I'd like to copy that on down, but before I do, I need to absolutize whatever I need to absolutize, that typically being something outside the table we're working on, possibly in the data set, in this case, that 9%. Double-clicking on the present value, there's the 9% in E6. Putting my cursor in E6, selecting F4 on the keyboard, $ before the E, and 6, absolutizing it. You only need a mixed reference, but an absolute reference is easier on the mind, and so that's what I do. And then I'm going to select those, put my cursor on the fill handle, and drag it on down. And so there's the 806 about again. There's no pennies, but you can see that process again. Now also note, you could do the whole thing without an annuity calculation at all, meaning I'm going to tack on one more calculation here. I'll drag it down one more time. This also being for the period 15 periods out, but this time we'll take the value of the bond itself and bring that back. And if we bring that back, this then should be our end result. So we've just made the whole thing our series of payments. So we had this last interest payment and then the bond. This then should be the end result. I'll make this one yellow right there because that'll be a little bit different of a calculation. But we'll do that again in a two-step process as well, which is probably what would be sought by a book problem. So then we're going to say that the payment is going to be, let's do it with the tables is what we're doing now. So payment still there. Table time, let's look up the table, making sure we have the proper table. It's an annuity table, present value. We're looking 9% and 15. 9 and 15, 9 and 15. That's 8.0607, 8.0607, 8.0607, 8.0607. Multiplying equals the 100 times the 8.0607 is once again that 80607. Interesting. Okay, any case. Then we're going to go over here and we'll present value the 1,000. So this is the second half of the problem. We did the annuity, then we're going to have this $1,000 payment, one-time payment, that's going to be 15 years out. We can do this with a formula. Now the formula's present value equals the future value times 1 over 1 plus r to the n. The future value is going to be the 1,000, 1 plus r, 10, the rate is 9% to the n, which is 15. So we'll say, I'm going to pull this to the outside, the 1,000, that one payment. We got a present value it using, this is the key. Remember that we're using the yield rate down here, not the rate on the bond, because that determines the amount of the payment, the 100. And then we're going to say this is going to be 1, and then the rate is going to be that 9%. Percentifying that. Home tab numbers, percentifying, underline, home tab font, underline, summing it up with the trusty sum function equals SUM, shift 9, up arrow, holding shift up again. Percentifying that cell, home tab numbers, percentify, taking it to the power of the number of periods, which in this case 15 in years, underlining that, home tab font group, underline, and then we'll pull this to the outside, calculating the 109%, caret shift 6, 15 number of periods, and then we'll percentify this, home tab numbers, percentify, and then home tab font and underline. And so then we're going to divide this last column, because that's the numerator over the denominator, adding a couple decimals, home tab numbers, couple decimals. So that $1,000 payment we're going to get at the end of 15 years is going to be equivalent in present values at the market rate 9%, $274.54. Now, if we add the result we got last time, present value of the annuity, which is the 80607 plus what we just did right there, present value of the 1, we get the 108061, which once again is kind of the price of the bond. So because the market rate is less, we got a price that's not equal to 1,000, which is what we would have gotten if the market rate equaled the rate on the bond. You could prove that to yourself by working this one time with the 10% in there. But it's going to be now higher because we're sitting here holding on to the bond saying, hey, you know, you can't get a bond and get 10% anywhere else. And our bond has 10% on it. So we'll sell it to you for $1,080, even though like the face amount is 1,000. That's kind of how the negotiation, you could think of the negotiation going. In any case, so let's do this calculation a couple more ways. Note that this 1,080.61 is similar to what we had over here, 1,080, right, 81, because we tacked on that last 15, which is the present value of 1 calculation. Okay, so let's do this again with the trusty present value of 1 calculation, negative present value, shift 9, rate 9%, comma, number of periods, 15, and then comma, because it's not an annuity, but payment of 1, future value 1,000. There it is again. Let's do it with the tables this time. Table time. Tables 1,000. Making sure we got the proper table, this time being a present value of 1 table. Our assistants have helped us out and always have the right table down here. It's wonderful. We have 9 and 15. That's going to be the 0.2745, 0.2745. So 0.2745, and then multiplying that out 1,000 times, that 0.2745 gives us that 274.50 again. Okay, all the way back over. Let's do, I'm going to scroll down now. I'm all the way back to A1. I'm going to scroll down to row 57, which will do the second part, which is 11. I'm 11% now. So this percent is greater than the market rate yield is greater than the amount on the bond. So now you can imagine the negotiation going something like this. We're holding on to the bond at 10%, trying to sell it and get money. And then the person on the market is saying, hey, look, I can go somewhere else and get like a bond that's the same really as the risk on your bond, and I can get an 11% return. And we want the money, and we're like, he's right. So, all right, we'll sell it to you for something less than the face amount, less than the 1,000. We have to sell it, in other words, at a discount. So now we're looking discount situation. We expect then the value to be something less than the 1,000 face amount of the bond. So let's do our same calculation. First, we'll do the annuity, P times 1 minus 1 plus R to the negative N over R. Same calculation here, except we're using the 11%, so I'll do this a bit faster now. 1,000 times 10% is going to be the amount that of the annuity payments for 15 periods. Then I'm going to say 1 here, and then we got the 1 plus R to the negative N. This is going to be 1. R is going to be now 11%. Percentifying that, home tab, numbers, percentify, underline, home tab, font, underline, summing it up with the trusty sum function equals SUM, shift 9, adding those up, and then we'll make that a percent, home tab, numbers, percentify, and then we'll take that to the negative periods, which is 15, negative 15, underline, home tab, numbers, underline, pulling this out to the outer column now. This equals the 111% shift 6 caret 15 or negative 15 number of periods. We need some decimals to know what's going on here. Home tab. What am I, a computer? I need some numbers decimalizing it. And then underline, home tab, font, underline. And so, wait, I don't need an underline there. What am I doing? So there, where am I at? Hold on a second. There, okay, yeah, underline. Home tab, font, underline. Now we'll take the 1 minus that number, and that'll be the end of the numerator. Into the numerator, decimalizing that home tab number, decimalize. Okay, now we got the denominator R, which is 11%. And then we'll percentify that, home tab numbers, percentify, underline, home tab, font, underline, pulling that out in the outer column, taking the numerator, dividing it by the denominator, and then adding decimals there, home tab, numbers, decimalize, and then underlining it, home tab, font, underline, and then we can multiply these together, this being the 100 times that number, and then we'll just add some pennies. Home tab, numbers, and add some pennies. Just 2 pennies. There's only 2 pennies. No more than, no hay pennies. So there we have that. And then we can do the same calculation with the Excel function. So for that, we'll move it on over here. And this is going to be negative present value shift 9, rate 11%, comma, number of periods now is going to be 15 again, 15 periods. The rate's what's different than the last time we did this. Annuity is going to be the payment of $100. Once again, there's the 719. So there it is, 719. Let's do that with a running balance, making this whole thing present value of 1 calculations and just eliminating the annuity altogether, which book problems don't really like because they're trying to force you to do book, the annuity, but you can do this and it's not that hard in practice. So we take these two and then I'm gonna auto fill that down, fill handle, drag in the fill handle, and then home tab numbers centering. Payment is going to be the $100, and now we'll do present value of 1 all the way down. Negative PV, shift 9, rate 11%, comma, number of periods, just 1 period out this time, comma, comma, future value 100. So there we have it. I'm not going to add the pennies this time. We'll make this nice and rounded. And then we'll do it again. Payment's always going to be the same $100, but the present value now is the PV shift 9 rate 11%, comma, number of periods 2 this time, second payment out, comma, comma, future value 100. Now we have the prior value plus the current value, and we want to add that down, but we need to make sure to absolutize anything outside the table, usually from the data set, that being the 11% in this case. Present value, that 11% right there, don't want it to move down. It's in cell E62. E62 cursor in there, selecting F4 on the keyboard, $ before the E and 62. You only need a mixed reference, but absolute is a little easier in my opinion, so I used it. Selecting those cells, fill handle, dragging down the fill handle to 15 periods. There we have it, and there's that 719 again. Let's do it again with the tables, because that's always good time. Table time. Payment, $100. Amount from the table, making sure we're picking up the proper table. This time, present value of an annuity. We're looking 11%, 15 years, 15 periods. 11 and 15. There's the 11. There's the 15. 7.1909, 7.1909, 7.1909, 7.1909, 7.1909. Multiplying this out, 100 times 7.0919 gives us the 719.09 because it's $100 times that. So anyway, so now, also just note that on this one, this running balance, we could actually do the final payment this way too and just remove the annuity altogether, meaning I might drag this on down and say, let's just present value the last payment. It's also 15 periods out, but it's for $1,000. So I'll just say, and then there's this $1,000, and there we have it. And there's basically the answer without pennies, 928, 928. Home tab font, I'll make this one yellow because that's a little outside, that little different. All right, moving on. Now the second component is the present value of that that 1,000 at the end, which is the present value of 1, which is the equal to the future value times or over or times 1 over 1 plus r to the n. So I'm going to put the future value outside here, which is the 1,000. We're going to take then the 1 plus the r to the n. So I'm going to say this is going to be 1 rate is the 11% down here. I'm going to make that green, so I'm less likely to mess it up. I still might, but less likely if it's green, because I know I work on the greens. That's what anyway. So now it's going to be home tab numbers percentify, and then home tab font underline trusty sum function equals sum shift 9 up, and selecting those two, and then we're going to percentify home tab numbers percentify number of periods now 15 again, underlining that home tab font underline, pulling that outside. This is going to be the 111% to the or shift 6 caret 15 periods, adding decimals, home tab font group decimalized, and then home tab font underline, and then we can divide finally the 1,000 divided by that number that we came to. Couple pennies, home tab numbers, couple pennies please. And we got the 209, no pennies. They're like, no, we're not going to give you your pennies. And we were like, well, I don't really want pennies. I just wanted to see if there was any pennies. I don't care if there's not anyways. So now we're going to say that we had last time this 719. I'm going to stop saying anyways too, in case you were getting annoyed by that. It's starting to annoy me. Sum of these two then, that's going to be the 92809. 92809. Okay, so then we'll do this again with the present value over here, negative present value, shift 9, rate 11%, comma, number of periods 15, comma, because this is not an annuity, present value of 1, and we'll just pick up the 1,000. I'll pick it up from there. There it is again. That's right. That's the one. That's the one. Let's do it one more time with the tables this time. 1,000. Making sure we have the proper tables down here, which is the present value of 1, 11%, and 15, 11. There's the 11. There's the 15. 0.2090, 0.2090, 0.2090, 0.2090, 0.2090, and this is going to be the 1,000 times the 0.2090, giving us, that's not right. Hold on, this is 1,000 times the 0.20. There it is, the 209. I must have hit time. I must have hit, I don't know, multiply, divide. I probably hit divide, but now it's right. So now let's do this one more time. We're going to do it this time with 14%. So I'm all the way back to column A. We're going to scroll down, do this one more time because this is good times. And we're going to do it this time with 14%. Once again, we have a percent greater market percent or yield greater than the amount on the bond. Therefore, in the negotiation, if we're the person selling the bond, we're like, we'll sell you this bond for $1,000, 10%. And they're like, we can get a bond elsewhere and we get a return of 14% on the market. Why would we buy your bond? And we're like, they're right. So we're like, okay, well then we'll sell you the bond. We can't change the percent, but we'll sell it for something under the 1,000 to compensate for the fact that we're only paying the 10% and other people apparently are issuing this 14. And so then we got to figure out, okay, well, how much lower will it be? So we expect then the price to be something under the face amount of the 1,000. Okay, so let's do that. We're going to say once again, the annuity part, P times 1 minus 1 plus R to the negative N over R, pulling then the annuity payment to the right. This is going to be the 1,000 times the rate, which is 10%. That's where that 10% comes into play. That gives us the $100 per period, 15 periods. Then we're going to say 1. Then I'm going to pick this up. This is going to be 1 plus the rate equals the 14%, which I'm going to make green again to try to avoid picking up the wrong rate. 14%, percentifying it, home tab, numbers, percentify, underline, home tab, font, underline, trusty sum function equals SUM, shift 9, up arrow once, 14 and 1, or 100. Home tab, numbers, percentifying it, then to the power of negative periods, which is 15, in this case years, underlining that, home tab, font group, underline, pulling that to the outer column now. This is going to be equal to the 114%, shift 6, caret, to the power of 15, or negative 15, I should say, because that's the proper thing to say, and I want to be right. So home tab, numbers, percentifying, or decimalize, home tab, font, underline, subtracting the 1 minus that thing we just got, which will finally get us to the end of the numerator, but we need to decimalize it. Home tab, numbers, decimalize, there's the numerator. Denominator is R, so we're going to pick up R, which is 14, the green number, which was easy to see because it's green. Home tab, numbers, percentify, underline, home tab, font, underline, bringing this to the outer column, taking the numerator, divided by the denominator, percent or decimalizing, home tab, numbers, decimalize, and then home tab, font, underline, and then finally we can multiply the outer column, 100 times that thing we just got to, adding a couple pennies, home tab, numbers, pennies, 22. Okay, so then we could do this with Excel function. So let's do that, which is going to be over here. This is going to be negative present value, shift 9, rate 14%, comma, number of periods is 15, comma, and then the payment, $100. So there's the formula and enter. There we have the answer again. Let's break this out to our present value of 1 calculations. 1, 2. I'm going to sum these down. These are the number of payments. There's going to be 15 of them. And then we'll go to the home tab, alignment, center. Payments are going to be the $100 in an annuity format. First payment then, what's the present value of the first payment out? Equals PV. Well, let's make it a negative PV. Negative PV, shift 9, rate 14%, comma, number of periods 1, comma, because it's not an annuity, future value 100. And there's the 88. I'm going to pull that to the value over here. Let's do it again. This is going to be equal to the 100 because they all equal 100 on the payment side of things. Payments are quite boring because they're all the same. This is going to be negative present value. This is where the action happens. Shift 9. Rate is going to be the 14%, comma, number of periods 2 now, comma, comma, future value 100. And there's the 77, so we're going to pick up the prior 88 plus the current 77. I'd like to copy that down, but I need to absolutize the percent because it's outside of our table, and typically when that's the case, we got to make that an absolute because I don't want it to move. That's in cell F124, so I put my cursor in F124, select F4 on the keyboard. That puts a $sign before the F and the 124. You only need a mixed reference, but absolute works, and it's easier. So I'm going to then hold the fill handle, drag it on down, and there we have it. So now we're down to the 614, about, rounded, no pennies added this time. We could also tack on the last payment if I wanted to drag this down one more time. I can drag it down, but this is still going to be a 15, not a 16, and I could pick up the face amount down here and get right to the answer, This is not the way a book problem probably wants you to calculate it, but you could calculate it this way and tell the book, you know, I'll calculate it the way I want to calculate it, and this works fine if you have Excel. And then they're like, well, you won't be able to use Excel on the test, so you probably don't want to piss anyone off. So you want to do it the way that they want you to do it, most likely. But you could do it that way, and in practice, it could be useful to do it that way. So lastly, we can do it with the tables, which is another way that a book problem might force you to use tables, which are kind of fun, but you know, Excel's would be faster, I would think. But in any case, the tables, we're looking 14 and 15 periods. 14%, 15 periods, making sure we got the proper table. And we're looking 14%, which is way out here. 15 periods, which is way down here. 6.1422, 6.1422, 6.1422, 6.1422, 6.1422. Multiplying that out, 100 times 6.1422, 61422, makes sense. Then we'll do the second half of this, which is the present value, the one-time payment. That's going to be 15 periods out, 15 years out, with the formula present value equals the future value times 1 over 1 plus r to the n. Bringing the payment into the outer column, that's going to be the 1,000. Then we have the 1 plus the r, so we're going to say 1. R is going to be 14%, which I'm going to make green. So I almost picked up the 10% right there because it wasn't green. That's why. If I did, it was because of the fault of the 14% not being properly colored. And then we're going to go home tab, numbers, and make that a percent home tab. Font, underline, and then we'll sum up equals the SUM, shift 9. Adding those up with the trusty sum function, percentify, home tab, numbers, percentify. Taking this to the power of the number of periods, in this case years, that being 15. Underlining that, home tab, font, underline. Taking this to the outer column now, that's going to be the 114%, shift 6, caret 15. Adding decimals, home tab, numbers, decimalize. And then home tab, font, underline. And then we're going to take the numerator divided by the denominator, finally getting the answer, but we want a couple pennies by going to the home tab, numbers, and adding the pennies, which in this case, 10 cents. And then down below, we've got the present value. This is what we got last time. Last time, this was the present value of the annuity. So if I add the present value of the annuity and the present value of 1, there's our answer, the 754.31. That should match what we have over here, 754, except we don't have the pennies here, but that's the same answer, I believe. So 754.31, and then we can do this with the present value calculation equals the negative PV, shift 9, rate, 14%. Now I see I almost got that 10 again, but it was properly greenified. So I picked up the proper percent, and then this is the number of periods, which is going to be 15, and then comma, future value, 1,000. There it is. Once again, that 140.10. And then we could do that lastly with the tables, rounding that out, ending it off with the table time. Making sure we get the proper table here, this being the present value of 1, 14%, 15 periods, 14%, 15 periods, 0.1401, 0.1401, 0.1401, 0.1401, 0.1401. And then we're going to take the 1,000 times the 0.1401, giving us the 140.10 again.